Good morning, everyone. My name is Ng Yuan Yi. Today, I will going to present my scientific poster titled as Effect of Temperature and Salinity on Coral Bleaching in Laboratory. This study was conducted by Kamorpon Patanasiris and colleagues from the Department of Marine Science, Chulalongkorn University, Thailand, and collaborating institutions. First of all, coral bleachings occur when coral lost their symbiotic algae, which known as zooxanthellae, or their photosynthetic pigments, which causing the coral color loss. Environmental stress issues, such as the increase of temperature and reduced salinity, can disrupt the coral-zooxanthellae relationship. The coral reefs are important marine ecosystems that support a wide variety of marine organisms. However, coral bleaching has become a major environmental concern. Therefore, the objective of this study was to investigate the individual and combined effect of temperature and salinity on zooxanthellae density and coral bleaching in cauliflower coral Poxylopora dimiconis. Indeed, in this experiment, cauliflower corals was collected from Salmonsan Island, Thailand. Then the coral were exposed to different temperature treatment of 27 degrees Celsius, 13 degrees Celsius, and also 33 degrees Celsius, as well as the different salinity treatment of 10, 20, and 13 PSU. During the 72 hours experiment, coral bleaching percentage and the zooxanthellae density released into the water were measured in every 6 hours. From the result, the researchers found that the combination of high temperature and low salinity will cause the most severe stress to the corals. For zooxanthellae density, under the highest temperature treatment, which is 33 degrees Celsius, the lower salinity result in the greater zooxanthellae release. So the most severe treatment was 33 degrees Celsius with 10 SPU salinity. The zooxanthellae reached up to 1087 cells per millimeter. This indicates that the stressful environmental condition that caused the corals to lose more zooxanthellae, which is shown at the graph figure 1. So the coral bleaching image at figure 2 also show the invisible color loss under the same treatment at 33 degrees Celsius and also 10 SPU condition. So the coral show approximately 10 to 90% bleaching before death. The figure 2 that shows after 18 hours, the coral exposed to the 33 degrees Celsius and 10 SPU salinity is death. So the result suggests that the temperature and salinity interact to influence the coral health. These two stress factors do not only act separately, but can have a combined effect on coral survival. So the high temperature will reduce the zooxanthellae growth and the photosynthetic efficiency, while the low salinity can further affect zooxanthellae function and coral health. Therefore, the coral experience multiple environmental stress at the same time, then the impact will become stronger. So in conclusion, this study shows that the coral bleaching is strongly affected by environmental change, especially the combination of high temperature and also the low salinity. So the most severe response occur at 33 degrees Celsius and 10 PSU, which cause high zooxanthellae loss and severe bleachings. So it is important to understanding all the stress factors for predicting how coral reefs may respond to future environmental change. So that's all from me. Thank you.